So hello everyone, welcome to another episode of Deep Dive Knowledge Talk. Welcome. Tonight we explore the complexities of translating embeddings across vector database, a challenge akin to language barriers with security implications. So discover Vec2Vec, a method for a universal vector space, enabling diverse applications from information retrieval to enhanced NLP while considering its potential risks. So what are the common challenges associated with translating embeddings from different encoders in vector databases? And why is this a really critical issue for data security?
Translating embeddings from different encoders in vector databases can be tricky because it's like trying to understand different languages without really knowing what they mean. Each encoder represents information in its own unique way, just like how different languages have their own words and like grammar. One major challenge is that when you try to translate these embeddings, you might not know the original data or the rules of the encoder that created them. So this can lead to misunderstandings or incorrect translations, which is like trying to translate a book into another language without knowing the story. So this issue is critical for data security because if someone can translate these embeddings without knowing how they were created, they could potentially extract sensitive information. It's like having a secret code that if broken reveals private messages. Like if attackers can decode these embeddings, they can access confidential data that should actually remain protected, making it a significant risk for organizations relying on vector databases.
How does the Vec2Vec method address the challenges of translating embeddings from unknown encoders, and what specific techniques does it employ to ensure accurate decoding?
The Vec2Vec method tackles the challenges of translating embeddings from unknown encoders just by creating a universal language for these embeddings. Just imagine trying to communicate with people who speak different languages. You need a pretty common language to understand each other. Vec2Vec does this by transforming various embeddings into a single sort of shared vector space. To ensure accurate decoding, Vec2Vec employs a few specific techniques. One like translation function, so it generates a function that can convert the embeddings from one encoder into the format of another. This is like having a translator who can take sentences from one language and express them in another, even if they don't know the original text. 2. Generative adversarial network. So GAN architecture Vec2. Vec is built on a GAN, which consists of two parts like a generator that creates new data and a discriminator that checks if the data is real or fake. This back and forth process helps the generator improve its translations over time, making them more accurate. 3. Input adapters. These are like special tools that prepare the embeddings for translation, ensuring they fit really well into the universal vector space. 4. Cycle consistency losses technique checks so that when an embedding is translated to another space and then back again, it should resemble the original embedding. It's like making sure that if you translate a sentence and then translate it back, it still means the same thing. So, by using these methods, Vec2Vec can effectively translate and decode embeddings from different encoders, allowing for comparison and extraction of sensitive information, all while maintaining a really high level of accuracy.
So, what kind of role does the Platonic Representation Hypothesis play in the functioning of the Vec2Vec method, and how does it contribute to the creation of a universal, latent kind of data structure for embeddings?
The Platonic Representation Hypothesis plays a really crucial role in the functioning of the Vec2Vec method by suggesting that different types of data, like images and text, are all reflections of a really common underlying reality. Think of it like different artists like painting the same scene. Each painting looks totally different, but they all capture elements of the same subject in the context of Vec2Vec. So this hypothesis implies that even though different embedding models create results in separate vector spaces, they are ultimately trying to approximate the same kind of ideal study of data. This shared underlying reality acts as a universal latent structure that Vec2Vec just aims to learn by understanding this commonality. So Vec2Vec can translate embeddings from various models into a single universal vector space. This is akin to having a master key that can unlock multiple doors, allowing the method to compare and decode embeddings that initially seem so dissimilar. As if Vec2Vec learns this universal structure, so it becomes increasingly effective at translating different residuals, ultimately leading to better performance across various types of data.
What kind of security implications arise from the ability of Vec2Vec to decode sensitive information from embeddings, and what measures can organizations take to mitigate these risks?
So the ability of Vec2Vec to decode sensitive information from embeddings raises significant security implications. Since the Vec2Vec can translate embeddings from different encoders and extract meaningful data, it poses a risk that confidential information, such as personal details like financial data or like proprietary company information, could be accessed by unauthorized parties. This is like having a master key that can unlock so many doors, allowing someone to see what should be kept private. To mitigate these risks, organizations can actually take several measures. One, data encryption. Encrypting the embeddings can help protect sensitive information. Even if someone gains access to the embeddings, they would not be able to decode the data without the proper kind of decryption key. Two, access controls. Implementing strict access controls ensures that only authorized personnel can access vector databases like. This is pretty similar to having a secure vault, where only certain individuals have the combination to open it. Three, regular audits. Conducting regular audits and monitoring of vector databases can help identify any sort of unauthorized access or unusual activity. This is like having security cameras to watch over a valuable collection. Like, for embedding anonymization, anonymizing or obfuscating sensitive data before creating embeddings can reduce the risk of revealing personal information. Like, this is akin to using a pseudonym instead of a real name. So, 5, training and awareness. Educating staff about the potential risks and best practices for data security can help create a culture of security within the organization. By implementing these measures, so organizations can better protect their vector databases and minimize the risks associated with the capabilities of Vec2Vec.
Can you elaborate on the potential applications of the Vec2Vec method beyond just security threats and how it could be beneficial in areas like information retrieval or natural language processing?
The Vec2Vec method has potential applications beyond just addressing security threats, particularly in areas like information retrieval and natural language processing. And here's how it can be beneficial in these fields. 1. Information retrieval. Vec2Vec can help improve search engines by translating different document embeddings into a common vector space. This means that even if documents are created using different methods or languages, they can still be compared effectively. For example, if a user searches for a topic, Vec2Vec can retrieve relevant documents from various sources, enhancing the overall search experience. So, 2. Cross-modal understandings in scope 2. So Vec2Vec can translate embeddings from different modalities such as text and images. It can facilitate better understanding between these forms of data. For instance, it could help in applications where users want to find images related to specific text descriptions or vice versa. So this ability to bridge different types of information can lead to richer and more informative user experiences. 3. Enhance applications in natural language processing. So the Vec2Vec can improve the performance of models by allowing them to learn from diverse data sources. By translating embeddings from different encoders, models can access a broader range of information, which can actually enhance tasks like sentiment analysis, summarization, translation. 4. Data integration organizations, so that work with multiple data types can benefit from Vec2Vec by integrating various data sets into a unified framework. So this can help in analyzing and making decisions based on comprehensive insights drawn from disparate sources. 5. Improve model training by learning universal latent structure. So Vec2Vec can really contribute to training more robust models that are less dependent on specific data sets. This could lead to better generalization and performance across various tasks and domains. So overall, Vec2Vec has the potential to enhance the effectiveness and versatility of applications in information retrieval and natural language processing, making it a really valuable tool in the AI toolkit.
What future developments or enhancements could be pursued for the Vec2Vec method to further improve its capabilities and applications in various kind of fields?
Future developments and enhancements for the Vec2Vec method could really focus on several key areas to improve its capabilities and expand its applications across various fields. 1. Enhanced multimodal integration as Vec2. Vec2Vec already shows promise in translating between text and image embeddings. Further advancements could aim to include more modalities such as audio and video. So this would create a more comprehensive system that can seamlessly integrate and translate information across diverse formats. 2. Improve zero-shot learning enhancing. So the zero-shot inversion capabilities could allow Vec2Vec to extract information from embeddings. without needing extensive training on specific datasets. So, this would make the method more versatile and applicable to a wider range of tasks and domains. 3. Fine-tuning mechanisms like developing mechanism for fine-tuning. The translation function based on specific use cases or datasets could improve accuracy and performance. This would be similar to like customizing a tool for a specific job to make it work better. 4. Sort of robustness against adversarial attacks. Just as security remains a concern, enhancing the method's resilience against adversarial attacks would be crucial. This could really involve training the model to recognize and defend against attempts to manipulate or mislead the translation process. 5. Real-time processing. Improving the efficiency of the Vec2Vec method to enable real-time processing of embeddings would significantly enhance its usability in applications like live search and interactive systems. So 6. User-friendly interfaces. Creating intuitive interfaces for users to interact with Vec2. So Vec2 broadens its adoption. This would make it easier for non-technical users to leverage its capabilities for various applications, such as content creation and data analysis. 7. Collaboration with other AI models. Integrating Vec2 with other AI models, such as those focused on natural language, understanding, or computer vision, could lead to just synergistic effects, enhancing overall performance and expanding its whole range of application. By pursuing these developments, so Vec2Vec could evolve into a more powerful tool that serves a wide array of needs in fields like information retrieval, natural language processing, and beyond.